Hi, good afternoon. Again, my name is Jean Schaffer, and we're going to talk a little bit about the current state of affairs and whether network evidence really is needed when you're talking about a security operations center anymore. So by way of introduction, I joined Corelight about a year and a half ago. I did that after retiring from the government, from the intelligence community, after working there for 33 years. I began my career working at the National Security Agency. I spent 30 years of my career at NSA, and the joy that I found working was really we were always on the cutting edge of technology. If you know anything about NSA's mission, we focus on signals intelligence. And so as many folks who come into NSA, I've spent many tours working in the SIGINT directorate. What that actually provided me when you're on the offensive side and you're trying to gather that signals intelligence from your adversaries, you learn pretty quickly what holes really our adversaries or yourself leave within your networks, within your IT infrastructures. And then when you flip over and become a defender, as part of my history of my career, I managed our NSA networks, the classified and the unclassified networks. I was also the authorizing official, the CISO for NSA. And I was able to actually use all of that knowledge that I learned about how we would attack our adversaries and put that into place when we were trying to defend our own self. As you can imagine, both NSA and DIA and any intelligence community is really a prime target from nation-state attacks, right? So they are trying to seek information, and they are looking for the weak points that we might have, just like we do that for the others. So after about 30 years at NSA, I decided to try another intelligence agency. So I spent my last 3 years at Defense Intelligence Agency. And I was sort of dual-hatted there. I was the CISO for DIA, but I was also in charge of running all of DIA's infrastructure. They call it the DOTIS environment. It's the unclassified, secret, and top secret environments of where we actually created and ran the infrastructure for defense intelligence. That's what feeds our military. All of our operations commands, that's where and how they actually get intelligence. A part of that DIA was to manage and run JWICs. If you're not familiar, JWICs is your top secret SCI network. It's really your highway that connects all of your DOD, your intelligence community, the president, or any of the other government agencies that really operate up at that top level. So really wonderful career, but from there, I've learned a whole bunch about networking and how do you actually protect the security for networks. So today what we're going to talk about is we're going to take a journey. We'll start, I'll remind you of how the internet started, right, and how simplistic it was. We're going to take you through the current, what the internet looks like today, and what challenges are we going to face. We're also then going to discuss, does network evidence really play a big factor in today's internet environment? And if it does, what are the new ways we need to start thinking about in engineering to make sure that you can get that evidence that you need when you're a defender, so you'll know when you're under attack or how you're going to mitigate that attack. So in the beginning, there was a network. If you go way back when, it was actually sponsored by the US government, right? It started as DARPA. DARPA created the original internet, then it moved to the National Science Foundation. And you can see the picture, this is from the early 1990s, that shows it really was nothing more than at that time kind of point-to-point connections. And the prime purpose was to connect all of the supercomputers, right, your mainframes, that was at the time. And they connected them at the line speed of a normal modem today, right? So think about that way back in the 90s. It was so simplistic. There wasn't things like encrypted protocols, right? You truly could use some tools and trace traffic as it went through. And then, if you remember anything about the early days, I love to talk about the cuckoo's egg. So this was a book, just to remind you of what it was, happened back in the 80s. It really was an astronomer who turned into a system administrator, who spied on a spy who was trying to obtain information from the US, right? So back in those days, the FBI really didn't have the authority. Like the intelligence community, we really weren't focused on helping customers or the community actually track a spy at those days, a hacker, in terms of any other way. So what Cliff Stoll actually did was, after the whole incident, he got permission to publish his true story. And so it traces the year-long effort he took and how complicated it was when he brought in the FBI and the police. And also our phone, AT&T, was a big portion that he tracked, that this hacker actually resided out in Germany, right? And then you had to get international governments involved in that. And at the end of the day, we will claim that he was probably the first person who found electronically the espionage, because the KGB was actually paying hackers in Germany to solicit information, military secrets, right, off of Milnet, off of our military bases, all of that. So it's a pretty quick read, but the key is it was simple. It was easy to do, clear text protocols, right, at this point. But as you know, today's internet is much more complex, right? So when we look at it, there has been huge exponential growth. It is going to continue on this path with new cellular services being added, wireless has been added. Most of the internet, studies show about 75 to 80% of the internet actually uses encrypted protocols, right? If you have encrypted protocols, from a network perspective, you can't really see the payload that's in those encrypted protocols. And all of you are aware that we live in a multi-cloud environment now. So most organizations have been able to get rid of their data centers, right, their hardware, and they're moving their workloads and everything else into the cloud environments. How do you protect the cloud? And since clouds, in the cloud, IP addresses really aren't that relevant anymore. So what do you do with network data? We're going to discover that in just a few minutes. And of course, remote working, you can work from anywhere nowadays, which is wonderful. But it brought about a whole new series of architectural changes that people have put into place, right? There's whole cottage industries that's popped up. So if you're looking at SASE implementations or CASB, right? All of that is about how do you actually connect and do things on the edge of the internet. You don't always have to come home to the mothership. And as the internet has exploded and we've added 5G, now 6G, IP version 6, and everything else, we now have, I think, crossed that tipping point that there are more unmanaged devices on the internet than there actually are managed devices. And if we compound that, think about what everybody has done over the last couple of decades. We've digitized everything, right? The days of going into an actual library or research center and looking through papers, everything is now online. And you have to worry about the access to all of that. Powerful attack tools. I won't mention that, like the shadow brokers from CIA and NSA had major breaches, and those are out in the open. But also you have the cyber criminals, right, who are very lucrative with this and actually turn zero-day exploits around in the matter of hours, not weeks anymore. And actually your ransomware and all of that is contributing to this. So what exactly are we going to do if you're a defender, if you're really worried about protecting the stuff? What has just been created is a perfect storm. So you have this really complex environment. Most of it is encrypted. You're putting everything at greater risk because you're digitized everything, right? And you need to really protect that information, even if you think about the privacy of what's happening. So what are we really going to do? Well, this is where we have our dilemma, and we really need to think about this. Does network monitoring still offer defenders the compelling vantage point that it used to from when the internet was very simple? I'm going to hypothesize that yes. And recent history has actually shown us this. So if we look at these two discoveries and disclosures over the last couple of years, this is where we're going to show evidence. So SolarWinds was our major supply chain attack, right? Why did it take so long to discover this? The people who did SolarWinds, the planning was actually brilliant on this. I don't want to say this was a great operations, but if you think about it from a purely technical standpoint, this was a great operation, right? They hid in plain sight. Their malware, right, was disguised in the normal network traffic that was actually happening. So one of the things I will say is, as the Mandiant researchers actually discovered this and disclosed this in December of 2020, when they had the ability to look back against the network evidence that they collected, that's when they actually were able to determine that the attack started probably in the spring of 2020. They were only able to do that because they actually had access to that network data. If you fast forward a year to 2021 and we look at Log4j, Log4Shell, another thing that you will find, right? The Alibaba cloud research team actually used network data to figure out that there was a zero-day vulnerability that had been in existence since 2013. And it was just at this time that they were actually discovering that. So both of these things, what was really awesome is once they were discovered, it was all hands on deck from all vendors, from everybody, to try to identify whether or not you as a customer or you as owning infrastructure were actually hacked. Were you subject to this, right? So you'll find the Zeek community, the Suricata community, everybody put out IOCs and detections. And the organizations that were able to actually quickly identify whether or not they were caught up in this were the ones who had network evidence, because that actually was the proof that they needed to show whether or not they had been had. So the one thing I want you to take away is, remember, attackers can't do anything except leave some traces on the network. But if you're not looking for those traces, it's pretty easy for them to subvert you. So again, I'll take you back, but the internet's very complex. There's a lot of encrypted protocols happening. There's new modern architectures in place. I do think we need to think about how are we going to revolutionize our thinking, get a different frame of mind, and start engineering in how we collect network evidence. So we talked a little bit about the encryption challenge. I would contest that it is surmountable, right? With modern tools and engineered visibility, you can still protect and understand what's happening within your IT environment. So we know there are many times, for policy reasons, for privacy reasons, that you have to keep that traffic encrypted, right? So when you can't decrypt, what do? You shake that box, right? Go back to when you were 4 years old and you were Christmas time and you had all those presents under the tree. How many times did you go shake that box to try to figure out what you could or couldn't figure out was under the tree that you were going to get to open? Well, encrypted traffic is a little bit like that. There's a lot of data that's actually resident within that encrypted traffic, right? You can figure out what the actual encryption algorithm is that they're using. You have all of the information about the certificates that's there. And because of all of that, you can make dozens and dozens of inferences about what's really going on in that encrypted traffic. Most NDR vendors, like Corelight, puts a lot of funding and time into the research and development to try to squeeze out everything we can from encrypted traffic. We look at things like the spacing between packets. We look at the sequencing of timestamps. We look at the correlation between traffic in one flow and another flow. And then, with the uniqueness of the encrypted traffic, sometimes we can actually detect whether or not somebody's typing or it's machine-to-machine transactions. The other things that we're very proud of is some of the things we've found is we can identify if you're running DNS through HTTPS or TLS protocols, right? All of that are points when you're looking at, from a defender's point of view on the network, at things you need to identify. But of course, when you're able to decrypt, we will still say you have exceptional evidence if you're collecting it, right? Nothing is better than the plain text to understand what's happening on the network. But even today's modern architects, you would think it would all be encrypted. It isn't. So let's take a minute and look at what some of these moving to the cloud and the new app architectures actually present us. If you're looking at how things are run within Kubernetes or the Docker system, any sort of container system, there are still ways that you can gather network traffic. Okay, we talked about within the cloud, the IP addresses really aren't that important anymore, and that's true. But there are ways that you can enhance what normally is shown in a network log, in a Zeek log. You can enhance it with things like what pod, right, is this transaction actually going to? And looking within the unencrypted portion when within the cloud you're moving back and forth. All of that is data that you can then look at and make inferences about and understand the context of what's happening in that traffic. If you want more information about that, one of the things I would tell you is, by all means, go to the Corelight website and look at the blog. We have a series of blogs that's specifically talking about the ways that we're thinking about and how are we integrating in some of this new data that's available into what we do currently so that we can supplement that. So are you a SASE or a CASB user? If so, are you worried about losing any of your visibility, your network visibility you used to have? Think about when you ran VPNs. Everything came into those systems that you actually owned, right? By the time you got there, you could 100% see what was happening. If you're using some of these new architectures, it's not quite as easy to do that. And so if you were in that case, we would actually ask you to talk to us, right? I left my email address up there. Contact us, because what we're really looking for are folks who might be concerned about their network visibility. And we're really looking for some design partners to see how we're going to integrate NDR into some of these new SASE architectures. I put Zero Trust up there. Let's talk about Zero Trust for just a minute. So the President Biden put out the executive order last year for securing up our nation. Part of what he said is move to a Zero Trust architecture. So that Zero Trust architecture is a lot of things to a lot of people, particularly a lot of vendors. I'm here to tell you there's not one vendor that you could just go to and say, give me a Zero Trust architecture and they can solve your problems, right? That's not how this works. Zero Trust is really about shoring up those things that we know needs to happen across the board. So it focuses on things like strengthening your credentials, having a centralized identity management system. And heaven forbid, that identity management system probably should be tied to your HR system so that you truly know that you're giving out credentials to people who work for you and what those people should be doing. They also talk about EDRs, right? Endpoint detect and respond. Yes, EDRs are absolutely needed. But on the other case, it also talks about you should have complete network visibility. The reason they're telling you about that complete network visibility, if you refer back to Rob Joyce's briefing this morning during the keynote, he talked about how most adversaries will go after your shadow IT. They'll go after your legacy systems. They'll go after things that you, as a normal defender, in your mind, believe has already been taken care of, so you're not even focusing on it anymore. So when you look at what is really needed for zero trust, don't you want a way to know when you're implementing zero trust that you can actually validate that the things you think you put into place actually are performing as they should be? That validation is also where network visibility and network data comes in. So we'll talk about this pendulum, right? We just talked about endpoint data. Endpoint data is absolutely needed. But if you look over the last 5 to 7 years, that has been pretty much the predominance of endpoint data. If you think that you're secure just because you're collecting all of your endpoint data, I'll point you back to the clause that we talked about that said the internet today has more unmanaged endpoints than it does managed endpoints. So these unmanaged endpoints don't have endpoint data, right? You can't run EDR on most of these endpoints that are in existence today. So EDR is great for your managed assets, right? It gives you the depth that you need for those endpoints. But you really need to marry up that depth of the endpoints with the breadth that network data gives you. So that breadth would include things, and it would show you things like the shadow IT that you forgot to actually turn the router off on. But it's on somebody's checklist to go ahead and decommission that, right? So you need both of those things, and so my hypothesis is I think we'll see over the next couple of years that the pendulum is going to be swinging back. What you want is that balanced approach to security. You want your endpoint and you want your network data. So what did we really talk about today, right? I hope I left you with the thoughts that said network data is pretty valuable. We showed how 2 of the largest incidents in the last 5 years, right, SolarWinds as well as Log4j, use network evidence, network data, to actually help them identify that there was even a breach, right, that something was happening. And although many people will just say, oh, great, I'll collect these flow logs, I'm going to tell you they're not sufficient, right? Sampling isn't quite sufficient when you're looking at discovering what truly is happening across your IT infrastructure. You should be using something like a gold standard like Zeek, right? Open source Zeek. And I don't know how many of you have been tracking the news lately, but just last week, Microsoft had its Ignite conference. If you are not aware, I suggest you go look up the press release. But Microsoft announced that they have integrated in Zeek with their Windows platform. And that network data powers the Microsoft Defender for endpoints, right? So what they have determined is, yes, they absolutely want that depth from your Defender endpoints, But they want that network data because that network communications that occurs on the device really is what will identify the early stages of an attack, right? So when you look at those two things together, that gives you sort of the breadth you need to understand what's really happening and how can you go about mitigating things. Hopefully you'll walk away with understanding that encryption isn't the end of network data, right? You really can get good evidence, additional evidence to supplement what you normally got with the encrypted data. And also, the new application architectures, when you're moving to the cloud, it takes a different way of thinking about network data because you're thinking so much more broadly than IP addresses only, right? You really are looking for the context and all of the richness that comes with those applications. How do you feed that in so that you're getting a clear picture of what's happening across your network, particularly when you know that you're not the owner of that cloud data, right? And do you really want to wait and call a cloud team, wait 24 hours for them to respond to you? You want, as a defender, to get as much rich context from that as you possibly could. You also heard, as we're continuing to move more and more to the cloud, it is going to become more of a target, right? Any place that has a consolidation of data is going to be a great target. It's our jobs collectively to make sure that we know how to protect that and how to defend against that. And also, we're looking at the new architectures for remote work, for edge compute, as an opportunity, not as a demise, right? Not as an obstacle to us. We believe there's a great opportunity, and we really do want to partner with whether it's government agencies, other vendors, or folks within this cybersecurity field to let's figure out how do we continue to get the best data possible for all of this. And my final thought is I'm going to leave you with even the most skilled adversaries leave traces in your network data. But that requires that you actually collect it. And it requires that you actually do something with it. Collecting it and not looking at your files really is just as bad as not collecting it. So with that, if y'all have any questions, I'm more than happy to take any. And, oh.
In regards to the Zeek with Windows, is there going to be any other additional integrations into Corelight with potentially gaining access to some of that data? Because I could definitely see that being useful in places where you can't get a network tap or something into some of those environments.
Absolutely. I brought Greg Bell here, our Chief Strategy Officer, who's going to tell you about that integration.
Yeah, sure. It's a great question, and the short answer is we don't know yet. We're watching really carefully. The two talks last week at Zeek Week, the open source conference from Microsoft, were riveting and really generous in the sense that they gave a lot of information. And the open source team is working to get those online really quickly. But the very short answer to your question is at the moment, they're not. As far as I can tell, Microsoft isn't imagining sharing that data more broadly, but it will be available if you're a Defender customer. I don't know that that will be their final answer, and I'm sure they'd be interested in your feedback about that as well. But from the open source perspective, it's really exciting development because it normalizes the idea that Zeek data is the gold standard, and wherever and however you can get it, you should do that. I wish I could be more specific. Sure.
Any other questions? If not, thank you so much. We are here if you happen to be one of those SASE users and want to talk to us. Otherwise, have a great evening. Thanks.
Thank you.